Okay, so my other video kind of got stopped and I actually got cut off. So I'm going to make like a part two here. And I'm going to go ahead and redo, start at on the back page where we have a difference of squares. And the last problem here was a difference of squares because x was a perfect square and 36 was a perfect square. It was 6 squared. And the difference meaning subtraction. Okay. And we have a formula for that. We kind of have a shortcut formula where we have a difference of squares. It's the base A plus the base B is our first factor times the base A minus the base B for the second factor. So if I look at number 11 here, my I'm going to rewrite this as x squared minus 9 is a perfect square. It's 3 squared. So my A is x and my B is 3. So I can rewrite the factors or write this as factors as A, which is x, plus B, which is 3, and A minus B. Number 12, 4 is 2 squared, x squared. So my A is the base 2x, excuse me, and 81 is 9 squared, so my B is 9. All right, so now I'm going to write the factors as A plus B and A 2x minus B, which is 9. Now, we also have what's called perfect trinomials, where where the products is ends up to be A squared plus B. We have when they're adding, and then we have when they're being subtracted. So if they're adding, they're going to factor to A plus B times A plus B. And the perfect square trinomial happens to fall in this pattern of A squared plus 2AB plus B squared. Now, let's take a look at this. 13. The 4 is actually 2 squared. It's a perfect square. I have my x squared plus, now this, we're not sure, definitely not a perfect square, so I'm going to leave it for now. And then my 9 is 3 squared. If you notice here, I have a perfect square here. I have a perfect square here. So this is going to factor. This is actually perfect because that 12x, I don't need parentheses, that 12x happens to be, now I'm going to put my A over here. My A is the base 2x. My B is the base 3. So this equals A plus B. So 2x plus 3. And another 2x plus 3. Okay. This 12 happens to be, don't forget that 2 times 3 times 2, that's where I get my 12. And of course, I have the x from the 2x. Okay. I have the 2 times the a, well, my a was actually 2x. I should have put 2x there. And then my b was 3. So 2 times this, I have it 2 times b, so b times a, which is 2x. So let's look at 14. 14, I have a difference. So let's figure out what the a is. 25 is a 5 squared, x squared minus 20x plus 2 squared. 4 is a perfect square. So my A is the base 5x. My B is the base 2. Just to double check, 2, the middle term here, I'm double checking the middle term, 2 times A, which is 5x, times B, which is 2. That's going to give me 20x. So this is going to factor to A minus B. So 5x minus B minus 2 and 5x minus 2 or 5x minus 2 squared. All right, this was the little chart. Don't forget about that. These look like some extra problems down here. Let's go ahead and do these real quick. Step 1, looking at my chart, are there any factors to take out? Actually, I can. I can take out a 5 from each one of these terms. And I'm left with x squared plus 4x plus 3. And I can easily factor that using the diamond method, or should be able by now to use your mental math or guess and check. X squared, this is a positive, and there's only 2 numbers to multiply to 3, 1 and 3. And then 16, I can actually take out a 2 from each one of these. 2 times x squared minus 16. Be careful, we're not done here. This 16 is 4 squared. So this is a difference of squares. 16 equals 4 squared. So I have 2 A plus B, which is 4, and A minus B, which is 4. This is the complete factorization of that. And that's all we're going to touch on for right now. It's quite a bit. Again, this number 9 was a pretty difficult problem. It's probably one of the more difficult ones you'll see. Don't forget to print out your factor flow chart if needed. I will attach that to Google Classroom as well.